Hello, welcome to everyone. Today we are going to discuss about the topic phase lock loop PLL, which is an important topic in communication engineering. The phase lock loop is an electronic circuit with a voltage or voltage driven oscillator that constantly adjusts to the frequency of an input signal. The PLLs are used to generate, stabilize, modulate, demodulate, filter, or recover a signal from a noisy communications channel. Now we will see the basics of PLL. The PLL is also called as phase lock loop and is basically a closed loop frequency control system which is functioning based on a phase sensitive detection. The phase differences between the input and output signals of the voltage controlled oscillator. The PLL circuits are frequently being used to demodulate the FM signals, making absolute with the Foster Seeley detectors. The other applications of PLL circuits include demodulation, FSK decoders, two-tone decoders, and motor speed controls. For synchronization and demodulation circuit, the PLL is used. The PLL can also be used in a clock recovery. For example, in an input bit stream along with the clock signal is transmitted, and by using that PLL, the clock signal can be separated, and then in order to get your original transmitted signal. We are going to see the block diagram of PLL in which it has a phase detector, low pass filter or loop filter, and then the voltage controlled oscillator, and then it is fed back with an input, that is a feedback is given to an input signal by using a divide by n counter. The first block will be the phase comparator or phase detector. As the name implies, the PLL compares the phase of the two signals and generates a voltage according to the phase difference between the two signals, that is the reference signal and the input frequency. The second block in the phase lock loop will be the low pass filter. It is used to filter the output from the phase comparator in the PLL. It is used to remove any components of the signals of the phase which is being compared from the VCO line. The third block in the PLL is the voltage controlled oscillator. It is a circuit that generates the output radio frequency signal. It generates a multiplied version of the signal which is given from the low pass filter. Then the output of VCO is given back to the phase detector in order to generate the error signal that is given with the help of a divide by counters. Now let us find how the PLL works. It gives one signal from the output of VCO, and then it is given with the phase detector. There two signals are getting multiplied together, and then by the process of multiplication we will get two difference in signals, that is one will be the summation of your signal and one will be the difference in that signal. The summation signal, that is higher order signals, will be filtered by the low pass filter, whereas the difference in signals will be sent at the output of low pass filter, that is in order to produce an error signal by the VCO. So by using this error voltage, it is possible to lock the VCO to the input frequency. By using this phase detector for RF applications, the balanced mixer is used, and for digital signals the phase frequency detector is used, or a normal XOR gate is used. We know the operation of XOR gate. When both the inputs are high, the output will be 0, and when one of the input is low, automatically the output becomes high. This is the feedback path that is given by the VCO to the phase detector. As we discussed, it is given with the help of a divide by counters. A phase detector is basically a comparator that compares the input frequency with the feedback frequency. The phase detector receives two digital signals, one from the input and other from the feedback from the VCO output. The loop is locked when these two signals are off in the same frequency and have a fixed phase difference. The phase lock loops are widely used to synchronization purposes in space communications for coherent demodulation and then to demodulate frequency modulated signals, and in radio transmitters the PLL is used to synthesize new frequencies which are multiple of a reference frequency. A demodulation of both FM and AM signals, the PLL is used, and in the recovery of small signals otherwise would be lost in noise. Nowadays, in digital wireless communication system, the PLLs are used to provide the local oscillator up conversion during the transmission and down conversion during the reception. In most cellular handsets, this function has been largely integrated into single IC to reduce the cost and size of the handset. Thank you.